Hello, my name is METİN ARIDAŞIR. This is 48th part of explanation of my theory. Today our subject is certain prediction of helium spectral series by ARIDAŞIR, by me. Here's some samples. Here, left side, ordinary data. Right side, my prediction computation. This is one of series of helium. Here, from 3 to 2, 164 nanometer. Comparing my computation here. Okay. Almost all of them almost same results. From data measurement, from my computation according to my theory and my formulas. Okay. I advise to compare these figures. Left side data, right side my computations according to my theory and my formulas. Here, spectral series of helium. Okay. We go back here again. Now. I hope you see. I hope. Here starting from n equal to 1. Okay, but don't forget, according to my formulas, ARIDAŞIR's spectral line series principle formula. Before this is the title, Certain Prediction of Helium Spectral Series by ARIDAŞIR, by me. But here, this formula, or these formulas, is valid for all atoms, for all spectral lines, and for all spectral line series for all atoms. ARIDAŞIR's spectral line series principle formula. All spectral series starting value is starting value. This is spectrum. Remember, all spectral series starting value is equal to n square multiplied by lambda EI, initial wavelength of proton bounded electron motion form. Concern enlarging and shrinking by effects of free electron motion forms successive waves. All spectral series starting value is equal to n square multiplied by lambda EI, or spectral series starting value SSSV equal to n squared multiplied by lambda EI. Okay. Lambda EI is usually the smallest electron's initial wavelength. Each spectral, not this, here, main spectral series starting lines, starting points, okay? Dark lines, n equal to 1, n equal to 2, n equal to 3, n equal to 2, 4, 5, etc. through infinity. And here, from here, n equal to 1, 2, 3, 4 to infinity. Okay. Lambda EI is usually the smallest electron's initial wavelength. Here, smallest electron's initial wavelength of helium is, remember my former video, is 22.78 nanometer. Remember, lambda EI for first electron, but we say in formula here, for instance, where is it? H, helium, and 2, okay? Because we squared electron number. Wait a moment. I don't want to confuse your mind now. Each spectral line related electron's initial wavelength, here 22.78. Each spectral line related electron's initial wavelength, initial imbalance, not disturbed yet, okay, not enlarged, and equal to 1 position, okay, not enlarged. Yes. Each spectral line related electron's initial wavelength enlarges or shrinks at the rate of n squared. N squared multiplied by lambda EI by the effect of free electron motion forms successive wave. And n, here, n is the effective successive waves number. Absorption is enlarging of proton-bounded electron motion form by the effect of successive wave. Okay, remember former videos I have told you according to my theory and my formulas that, okay, like this, again and again and again. Here. Say here proton, okay. And now this is proton-bounded electron. And here lambda EI, helium 2. And bigger one electron I don't want to draw here now. And here free electron motion forms successive waves is coming. Okay, and this is direction of cycling. And when come in here, first, second, fourth, fifth, sixth, seventh, and eighth. Okay, lambda EI, H2 square lambda EI 64 multiplied by 2278 here. Whoa. It enlarges to 1457.92. For instance, okay. Enlarged. This is absorption, and when this effect, free electron motion from successive waves effect, vanishes again, shrinks its initial wavelength, it's in balance situation, and while shrinking, produce and push a single wave pulse. Okay, like this. Yes. Absorption is enlarging of proton-bounded electron by the effect of successive wave of free electron motion form. Emission is producing and pushing a single wave pulse sphere by bounded electron motion form when successive waves effect vanishes and when bounded electron shrinks or shrunk. Okay. And single wave pulse representative wavelength energy is equal to the difference between shrunk wavelengths and square lambda EI shrunk energy and enlarged wavelengths and square lambda EI enlarged energy. Okay, wait a moment. Here, we understand. First series starting value is 22.78 nanometer because of this is first n equal to 1 and squared lambda EI is equal to 22.78 nanometer, and this value is starting value of helium spectral series, first series starting value. Second series starting value is 2 squared, second, okay, 2 squared multiplied by 22.78 is equal to 91.12 nanometer. Then third starting value of helium series is 3 squared multiplied by 22.78 nanometer. It's 205.02 nanometer. Okay, and each one corresponds their energy. For each energy, it's themselves. Okay. It's this value's energy sample 87.18 joule. For this second value 21.79 joule, its energy, enlarging position, and cycling new balance, new in balance, but new step. Cycle. You see. Okay. Now, here. Yes. I hope you see now. I will explain this now. Okay. Emission and single wave pulses representative wavelength energy here and single wave pulses representative wavelength energy, bounded electron motion form produces and push a sphere through the eternity at the speed of light. This is not photon. According to my theory, this is a sphere, whole direction, okay? Enlarging sphere at the speed of light from bounded electron motion form, and usually it is isotropic, but successive waves of relocating in motion-free electron motion forms and isotropic. Two types of light. This is single wave pulse is one kind of that two, according to my theory and my formulas. Yes, here single wave pulses representative wavelength energy is equal to the difference between shrunk wavelength n²λei shrunk energy and enlarged wavelengths energy n²λei enlarged. Here, this is my formula for energy of single wave pulse. Then we computed its representative wavelength here, and each line's wavelength is representative wavelength according to my theory and my formulas here. Okay, firstly, n equal to 2278 nanometer, lambda EI 2278, and corresponds energy 87 point etc. n equal to 2. Okay, this is my formula, n squared. Okay, then this is energy, n equal 3 here, 200 like this, n equal to 4 like this, n equal to 5 its wavelength, n squared 2278 nanometer according to my formula. That's the magical figure, not magic according to my theory and my formula. 22.78 for helium's smallest electron motion forms wavelength. Helium spectral line series determinative wavelength it is. Okay. Now, here each n equal 5 n squared and corresponds energy. Now, how can we easily predict and compute from 3 to 2? Example. This is computing machine. Here. Now I will do from 3 to 2. Okay, from 3 to 2. Now 9.686 minus 21.795 equal to 12.109 12.0.109. Again, from 3 to 2. Okay, I will do this. I will find energy and then wavelength. Okay, wait a moment. Equal to 12,109 divided by 12,109 equal to, yes, here, 164, okay? Almost same. Now, from 5 to 2, for example, from 5 to 2, okay? Energy from 5 to 2, difference 3.48, 3.487 minus 21.795. Okay, 18,300. What? 5, 2, 2. Yes. 18 joule. 1986 divided by 18. Divided by 18, 308 equal to, here, 108.4, 108 point, here, almost same, okay? Like this. For example, this is Pickering series. My former video, I have predicted and I have told you. Okay? Now, say, from 9 to 4. Where is 9? Here. 1.076 minus 2, 4. Yes, 2, 4. 5.448 equal to 4.372. Okay, 1986 divided by HC. Okay, divided by 4.372 equal to, here, you see, I guess, 454.25. Yes, here, 454.1. My computation, 454.25. Almost same, like this. Okay. I will go on to tell you all my theories and all my formulas with examples, with experimental proofs. Have a good evening. See you later.